Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. Today I have one simple, short, sweet, and I promise you, not scary, definition to give you before we can move on to my favorite lemma. So let us hope that we get the right whiteboard. Beautiful. Everything that we need to define actually the most important thing that we could possibly be defining, which is the notion of a canonical model. We've been talking about them for a very long time and we've done bits and pieces, but now it's time to bring everything all together. So here's our definition. It is of canonical model, and you will recall that canonical models are always defined with respect to some particular logical system S. So we will indicate this by superscripting our fancy M with an S. And it is a triple WS, RS, VS, and that is it. There is the canonical model. Of course, hopefully you're sitting there being like, thanks, Dr. Logic. That is a series of symbols. It doesn't actually tell me anything useful. So just to recap, because we've defined parts of these before, but let's bring them all together. WS is going to be the set of all maximal S-consistent sets, and R is going to be defined such that, remember the box minus notation that we had. So it is a binary relation on the set of worlds. So one way that we can write this slightly more mathematically is that it is a subset of the cross product of WS by WS. And it is a binary relation that is such that two of these maximal S-consistent sets, delta and gamma, are related to each other by this relation if and only if the box minus of the first is a subset of the second. And that's what we've just seen. So now what we need to know is we've got our worlds, we've got our relations between them. How do we evaluate the propositional letters? Because remember, this is a model. It's not a frame. We define one particular way that you can assign truth values to the propositional atoms in the various worlds, and you've got to respect that definition. Otherwise, you might have a frame that looks like the frame for the canonical model, but if the valuation is different, it's not the canonical model. But luckily, it's quite easy. So VS is evaluation. So it is such that if P is a member of a particular maximal S-consistent set, then that will be the case if the value that P gets at that set, at that world, is true. And this is a biconditional, but we start with knowing what atoms are in which sets, and then we use this to generate the assignment for the atoms. And then, and this is where the cool part comes in, the truth and membership lemma, which we will prove in the next video, shows that this valuation works in the sense that right now we have a correlation between atoms being true and atoms being members. So P is true at a world if and only if it is a member of that world. But we can generate this for propositions of any complexity all the way up as far as you want. Truth and membership are always going to be correlated. Do you see why that's so cool? Anyway, it's so cool. I hope to show it to you soon. Until then, take care. Don't get too scared by the logical theorems out there. Cheers.